everyone, and welcome to a workshop for the Bear Necessities Hackathon. Today, we're very lucky to be joined by Sean Au from Subquery and On Finality, and he's going to be giving you a talk today about building a combined Substrate and EVM NFT indexer. Now, Subquery is one of the sponsors for the Bear Necessities Hackathon, and they have a really interesting bounty, which we'll talk about, of course, today. And it's fantastic because the idea is already out there for you. You don't have to do any crazy ideation or sort of rack your brain to figure out what you want to work on. They have a phenomenal challenge all laid out right for you, which is really, really interesting and something that you can sink your teeth into. So Sean is a token researcher and an educator at Subquery. He's also a published author. He's written a book called Tokenomics, The Crypto Shift of Blockchains, ICOs, and Tokens. So Sean comes with a huge amount of experience, and we're very lucky to have him here today. So with that, I want to hand it over to you, Sean.
Awesome. Thank you very much, Kevin, for that introduction. And great to be here, and welcome to everyone as well. I hear that you can see my screen and you can hear me clearly. So let's move on to the next slide here, where in the agenda, what I'll do is a quick intro into Subquery here. We'll then take a look at some of the bounty challenge. And then the most interesting part is we'll go and take a walkthrough of a startup project. We'll go build something, right? I'll show you how it works. And then I'll take you through another walkthrough of a multi-chain example project. And after that, we'll finish up with some next steps and how we can continue supporting your journey in learning indexing, blockchain, and your hackathon as well. All right, first of all, just a bit of background about myself. As mentioned, I work at Subquery here, and one of my hats that I wear is a technical educator, sharing the knowledge. And one of my main beliefs is that learning is doing. I mean, I could speak for hours, but you don't really learn much until you get in with your hands-on project, and experience how things work. So learning is doing is one of my mantras. So hopefully we'll do a bit of that today as well. In my past experience, I worked for about 8 years at Atlassian as a trainer. And then I had the privilege to also work at Consensus and Chainalysis as the APAC educational manager as well. Again, sharing the blockchain knowledge to enterprises in Asia Pacific. So first of all, what is Subquery? Well, you may have come across it before, but if you haven't, it's an open source project that allows yourselves as developers to index, transform, and query a blockchain data to power your applications, right? And you can think of it as a custom API for your dApps or your decentralized apps, because if you're going to power your applications, you've got to get the data from somewhere, somehow, right? So why are we doing this? What is the actual problem statement or the thing we're trying to solve? Well, there are actually a number of problems, but just a couple of main ones here. The first one being the query speed, because getting data from the blockchain is actually it can be tricky, and it can take a lot of time. Right? I mean, that's one issue there. And the second issue is that the data out there exists on a lot of different chains. And as you may know, inside Polkadot, got a whole bunch of parachains. So back in the days, getting data from one chain, way back, it was the Bitcoin blockchain. It was nice and simple. But with this ever-growing multi-chain world that we are working in, getting data across different parachains and even outside Polkadot, the other chains in the ecosystem, can be quite challenging. So what do we do? Well, one of the solutions is you can actually build your own indexer, right? And a lot of companies do this, but the question is why, right? Why waste your time building your own indexer when you can focus on doing what you do best? And that is developing your application. Why worry about the incompatibility of different parachains as well? And once you've got this up and running, well, why do you want to worry about managing your own production infrastructure, right? And of course, the other option there is to use a third-party solution. And why not use Subquery, right? That is one option you have out there. But the question is, why would you want to do this? Well, first of all, Subquery is a leading multi-chain data indexer in the ecosystem, right? Because we started from Polkadot, we've architected the solution to be multi-chain from day one. We focus on speed. We know that time to market is really important, right? So we want to make Subquery faster than the other options out there with advanced indexing caches, pre-computed indices, etc. So not only getting the data is fast, but actually your development environment is quick as well. And I'll show you this when in the walkthrough, because we use a Dockerized container environment. Next up, we are flexible as well. You can build your own custom APIs using a GraphQL schema definition, and you'll be able to index and transform the data to suit your needs, right? And that's where the custom coding comes into place. You can transform, you can aggregate, you can continue to get data from another third-party API, such as CoinGecko, for instance, and then bring it in, continue to further transform it, and then store it in a database, then making it available via an API to your application. We're also open, as mentioned, open source SDK, allowing developers out there to adapt or extend Subquery to suit your own applications inside your tech stack. And finally, we're universal, as mentioned, being multi-chain engineered to work across a lot of the leading layer 1 blockchains as well. So not only in Polkadot, but across the likes of Cosmos and their various 58 zones. We're not integrated to 58, only about 11, and then the other ones as well. But in this particular workshop, we'll focus on the Polkadot ecosystem, of which we are integrated to quite a few, and I'll show you some examples very shortly. If you do have any questions, by the way, feel free to chuck it into the chat. I can see them here and try to answer them as I go along. Okay, so getting into the details a bit here, in a Subquery project, you can think of it as like a set of instructions on how to index the data. Right? And there are three main things that you have to focus on when you're creating a simple Subquery project. The first one is the GraphQL schema. And we tend to think of this as defining the shape of your data. So trying to figure out what information do you want to grab from the blockchain that your app needs. For example, it could be the sender, the receiver address, it could be an amount, it could be the token unit, it could be the transfer, right? Next up, we've got what we call the project manifest file. And this is the configuration file, because once you've defined what data you want, you need to tell the Subquery project where you're going to get the data from. Typically, this would be an endpoint somewhere. It could be a public endpoint. It could be a private endpoint with an API key, etc. And then the last piece of the puzzle, number 3 here, is the mapping file. This is where you do the coding, the transformation of your data into what you need before it's stored on a database and then made available to your application. So again, 3 simple main steps. Okay, so that was Subquery at a very high level there. Let's take a quick look at the bounty, which you can find at github.com Subquery Developer Guide. And let me just pull this up as well on my screen. Search for it. developer guild, by the way. Let me just exit out of this, bring this one across. So I'll just copy this into the chat for reference for those that are interested as well. You might want to bookmark this, and I'm sure the slides will be made available afterwards as well. This one here, the EVM indexer, what we're looking for is for someone to, or a team to create a Subquery project that indexes the ERC721 NFT from Moonbeam, Moonriver, A-Star, or Shiden, right? And this has to use the Subquery multi-chain indexing solution, which I'll show you shortly, and a couple of user stories, right? What we'd like to do is be able to view information about the NFT. So name, description, the collection, the price of the NFT, and the owner. And what we've actually done is we've given you a starting point on what the GraphQL schema would look like. Now, it doesn't have to be exactly like this, but this is a guide, right? So it doesn't have to match it exactly, but you will need to retrieve certain data points from the metadata. You see here we've got the contract address, the amount, the collection, the timestamp, etc. And we've got two entities here. We've got NFT one and also the collections entity, and a couple down below as well, NFT transfers, addresses, and network, right? So I'll explain what all this means in the very simple demo coming up. But again, this is just a indication of the challenge or the bounty that we've got for this particular hackathon. Okay, let me jump back to the slides here. Now, if you are pretty keen, you're in front of your computer, you want to follow along, you can do so. However, what you will need is Node, you'll need Docker as well, and you'll want to install the Subquery CLI. And you can do this with npm install -g for global, and then add Subquery CLI. Let me see if I can copy this into the chat. Again, if it is convenient for you, feel free to do so. And then there's also our documentation guide here that you can keep for reference, and that's also in the chat as well. So you'll see that Node and Docker are the prerequisites. Here's the Subquery CLI command to get up and running. Okay. Jumping back to the slides here. Now, what you'll see in the project are 4 repetitive commands, and we're trying to make things nice and simple for you, right? The first one, when you start a project, is you want to run yarn install. And this is pretty basic. It installs the dependencies, so no dramas there. Yarn code gen is the next one you want to run to auto-generate the types, and I'll share what this means shortly. Then we want to build the code with yarn build, and of course, anywhere you see yarn, you could replace with npm as well. And then yarn docker, start docker to start the container. And everything I'm going through today will be supported. There are already some YouTube clips and recordings of what I'm about to go through. So you can either catch this recording or go to YouTube and catch the various tutorials there as well. Okay, so the first thing I'm going to do is jump into our GitHub repo and create this starter project demo. So let's go into, first of all, let's do GitHub. And if I type in the word starter here, you'll see that we've got a whole bunch of startup projects for the different chains that we support. So Cosmos, There's Ethereum, Near, Flare, Algorand, etc. But I'm going to jump into SubQL Starter. This really should be prefixed with Polkadot or Substrate, because this is where we first started. So we didn't name it in the right way. But in here, you can see we've got a very large number of different parachains that we support. And I mean, Moonbeam's in here, Moonbeam, Moonriver, you can see. But what I'm going to do is just quickly go through the Polkadot starter here, and you'll see why in a second, right? So in VS Code, what I'm going to do is, because I've got the CLI already installed, I'm going to run the subql init command. And this is the starting point, right? Let's call this simple starter demo. Okay, just the name of it. And then I'm going to, oh, sorry.
Sorry, Sean, that's okay. Just to clarify, is this after users have run installed Docker, installed Node and everything?
Yeah, exactly.
Cool.
In particular, once you've installed the command line tool, you get access to this. Once you've done this, the CLI will ask you, what chain or network family do you want to use? I'll click Substrate, and then you'll see down here we've got, if I type MO, there's Moonbeam. Specifically, I'm just going to go to Polkadot, do a starter project. And then from here, I'm just going to hit enter and accept all the defaults, right? It's no big deal. And then I've got the folder, the project directory called Simple Starter Demo. Let me cd into this folder. And going back to the slides, remember, see this one here. I want to run yarn install, right? So that's the dependencies install, like so. And while that's downloading away, let's jump into the schema file here. Because remember from our presentation here, we've got the three main parts. One of them is a schema file. So this one here defines the information we want to extract. This one here is really simple. In fact, it's so simple we don't have a name for it, just field 1, 2, 3, 4, 5. Right? But I'll show you a practical example after this one. The second file is the project YAML file, right? This one here. Step number 2, the configuration file. And what this file looks like is that we've got the chain ID, we've got the endpoints, so this is where we're going to get the data from. We've got the start block, so we can define that as the Genesis block, or we could start somewhere midway, it doesn't matter. And then we've got 3 handlers, the block, the event, and the call handler. Right? And again, I'll elaborate more on these shortly, but the purpose of this sample project is almost like a connectivity test, right? You can basically get a project up and running in a couple of minutes with a couple of lines of code. So here I've got the appendices installed. Let's run again yarn code gen. Go. And again, I'm just going to go back to the commands, go gen. I'll then run build, and then I'll start Docker. Let's go yarn build. It's kind of like a pre-flight check, right? When you want to start a project, if you get any errors, then you want to sort those out first. But the starter project should be error-free, right? Yarn start Docker. So I've got a Docker container in the background here. See, I've got the simple starter demo, and it's actually got 3 containers inside. There's the Postgres database, there's the node, and there's the GraphQL engine. So once this is running, let's go to our browser on localhost 3000. Here we go. And I've already got the query here, but if you don't have it, you can always go to the README. Down below, you can just copy this out. And then if I hit run, there we go. You can see the total count is 300. Go back to Visual Studio Code. There we go. Move this out the way. And now I'm at 700. So it's indexing away, right? So this is a good sign, right? It means everything is working. We're connected to the blockchain, up to 900 now. So what I'll do is I'll stop this. And just a note that if you do sometimes get an error, the most common error will be an API limit, because at the moment I'm using a public endpoint. So here you can see I've got too many requests, please apply for an API key. But ignore that for now. This is the very simple project that, jump back to our slides.
And users can always use like a paid endpoint or a dedicated endpoint that maybe gives them a little bit more. Or if they're running their own Moonbeam node, that's a great option as well. Or yeah.
Exactly. And there are a lot of options there that give you a free API key and an API limit, a generous limit as well that you can use.
And Sean, I just had a quick question. So you specified the starting block as 1. Are there scenarios where users might not want to have, the Genesis block? They might want to start at like a later point in time?
Yeah, exactly. There are lots of scenarios where that happens. For example, if there's a specific contract that's been deployed maybe 2 weeks ago, the starting block will not be 1, right? And of course, you can go there, figure out the starting block, and then change it there. Okay, so that was quite simple, really quick, just to demonstrate the fact that we only had to run 4 lines of code. It took about 5 minutes, but it wasn't really useful, right? I mean, you can't really do anything with that. So the second example is going to be more specific, where I'm going to take you through this multi-chain project demonstration. So let me copy this GitHub repo here. Again, I'll paste this into the chat as well. What I want to do is get you used to understanding the schema file, and then the configuration file, and then also the mapping file, which I didn't show earlier, but I'll show you now. And this is in the source mappings folder. And this is really the coding or the guts of the project, right? Because you have your functions, you can transform, aggregate it all inside this one particular file. So what I'll do now is let's jump into the multi-chain project example. So I'm just going to copy this. So I'm going to clone this repo, right? Let me blow away all these files here. I had this earlier, so let me delete this. I'll go back to my root folder, and then I'll go git clone down below here. And I'm going to clone the multi-chain example. There we go. So I've got this example here. So the first thing we do is let's jump into, again, the schema file, right? What kind of information do we want? So here you can see an actual practical example where we're indexing transfers, right? So we want to grab the from address, the to address, basically the sender or the receiver. We want to grab the amount, and we're also grabbing some information such as block number, transaction hash, and the network that it's coming from, because this is going to be multi-chain. We've also got some other entities or objects here, and you can think of these as database tables, right? Because all the information will eventually be stored, in this particular case, in a Postgres database. So these are basically tables that are linked or related to each other. Next up, our configuration file, right? We saw earlier it was the project YAML file. Let me show you this here. So remember this file here, the project YAML file. Now, what's interesting in a multi-chain project is that we're going to have a configuration file for each chain. Right? So if you're integrating and grabbing data across 4 chains, you'll have 4 manifest files. This one is the Polkadot one. It's got the Polkadot ID, the Polkadot endpoint, excuse me, and then the filter or the handler. And I'll show you what this means shortly. But what we're really doing is we're filtering the blockchain data on the balances module and the transfer method. So if I deleted the filter like so, what that means is I'm actually going to index the entire blockchain, right? Because I'm not filtering on anything. That's kind of not true because I'm actually got the event handler. But if I do have, say, a block handler, then it will be downloading every single block and indexing all the data. And that's going to take a long time. So we don't really recommend indexing the entire blockchain, right? If you do that, you might as well run a node. The advantage of Subquery is being able to grab specific data sets for specific contracts within minutes, right? So if you're trying to index the whole entire blockchain, first of all, you've got to synchronize and download the whole data from Genesis block, and that could take days or even weeks. Right? So this is the manifest file for Polkadot. For Kusama, again, we've got the Kusama chain ID, we've got the Kusama endpoint, so it's all Kusama related. Right? We've also got the same handler and filter as well, right? Because we're trying to get the same data from two different chains. So that's the configuration file. And then the last piece of the puzzle will be the mapping file. And this one here, I minimize this. Going through this, what you can see is that we've got two functions here. We've got the handle Polkadot event and the handle Kusama event. The reason why we've got these is that if you look on the right-hand side, we've got the handler name called handle Polkadot event. So whenever an event is triggered or found, the project is going to trigger the handle Polkadot function, which is this one here in our mapping file. And the same thing for Kusama. So just think of it when some data matches our filter, this handler function will be triggered, which will trigger the function in our mapping file. And what it actually does is it records the network that it's coming from. And this E is actually a variable where the event payload of type substrate event is then captured, and then it's passed to another function called handle event, which really does all the work, right? So inside here, what we're saying is we've got the event payload, the data. We can strip out or access the from address, to address, the amount as well. And then we go and do some transformation. The first one here is we decode the address into a generic format. We've got some logging information that we can log to our console for debugging purposes. And we've got some helper functions here, such as ensure account, to make sure that the account exists. If it doesn't exist, down here you can see ensure account. It will go ahead and create a new account object. From here, we go ahead and create a new transfers object. And this transfer here links to our schema file. Over here, you can see we've got the transfer entity or transfer object. And what we end up doing is populating the fields we want to capture. So we've got the block number here. We've got the amount, transaction hash, for example. And this information can be accessed from the event object. And with the autocomplete libraries included, you just go event dot and it's block.block.header.hash, etc. That's how you access the specific information inside a block. So this is really the engine room from here. So next up, I'm going to run this. So let's go ahead and first of all, I'll run a yarn install just to download the dependencies, which I already have. The second step is to, let's go back to our notation here, is to run yarn code gen. Now this one's slightly different because for a single project, what we do is, second here, you saw me run yarn code gen before, right? But this one won't work in a multi-chain project. And the reason being is it is expecting to find the project.yaml file, but we've renamed it because we need one for each chain. So what I need to do is, first of all, I'm in the wrong folder actually. I need to cd into my multi-chain project. I always make this mistake. Let's yarn install again to download the dependencies, which will take about a minute or so, depending on the internet speed. And then once that has finished, I can then run yarn code gen. But if I go back to my README, what you'll notice is I need to pass it an extra flag. And this is the -- file flag to point to the actual manifest file, like the project.yaml file. Because it's actually looking for the default, which is project.yaml, instead of the new name that we created. Now you can point to any manifest file actually. It could be the Polkadot one, it could be the Kusama one. It doesn't actually matter. And a lot of people ask, well, why doesn't it matter? That is because if I open up the Polkadot one, for example, it's really looking for this line here. It's, oh, not this one. It's looking for the schema file here. And all the manifest files, they all point to the same schema file because you only have one, right? So it's going to look for this particular file, and that's why it doesn't matter which manifest file you reference. So what I'll do is let's go yarn code gen. And again, this will give an error because it's saying it couldn't find the manifest file. So what I need to do is go yarn code gen -- file dot / project. And again, this could be Polkadot, it could be Kusama, it doesn't matter. Hit enter. And there we have it. It's gone ahead and auto-generate the types. Now, what do I mean by generating the types? Well, on the left-hand side, you should see a new folder has appeared called types. I can open up the models, and it's generated the account, generic substrate, the transfers, etc. And if I open this up, you can see that it's got at the top auto-generated, do not edit. So it's gone ahead and done a lot of the hard work for you. And if you actually look at this file here, you'll see that scrolling down, it's basically got a bunch of, you can call them like getter and setter functions, where you can get data, you can remove, you can save data as well. And it's all auto-generated. You won't have to worry about this. So going back to our slides, we've done code gen. The final two steps will be to build the code and then start the Docker container. So again, let's go yarn build. And of course, you may be familiar with building. All it does is create an extra folder, a distribution folder. And then after that, let's go ahead and inside the Docker, I can't increase the font size here, sorry. I'm just going to delete the multi-chain demo. Let me delete everything. And I'll run start Docker. So yarn start Docker. And then we'll see Docker spin into life. Here we go. It's downloading the images, the containers. And you should see here, we've got a specific node for Polkadot and then one for Kusama as well. So we've got these 4 images. And what I'll do now is jump into the README file. And there's an example query that I can run. So this one here. So let me copy this. I'll go back into my playground here, and let me go and paste the query, hit run, and you can see I've got some Polkadot data coming back, which is great news. I've only got one because I'm doing first one, but if I delete this, you should see I've got 122. So it's indexing away, right? And it's got network from ID. And what I'll do next is let me go to the filter. I'll change this to Kusama. Run. I've got no information from Kusama yet. Might take a couple of more seconds. You see it's indexing away in the command line down below. Taking a while. And of course, it does depend on the endpoint, the network that you're on. Polkadot's coming through. Kusama's still a little slow. Oh, there we go. So we've got some Kusama coming back as well. 343, 615 as well. Now I'm going to just stop this Docker container because I do know that the Kusama endpoint is severely rate limited. So I'm lucky it came through. I'll hit the cap soon. But what you can see is a very simple example of grabbing data all within one project to Polkadot and to Kusama. So linking this back to the bounty, for example, your challenge, should you decide to accept it, is to repoint this to the likes of Moonbeam, to A-Star, etc. You've been provided the schema file. Once you've got the information, you can aggregate, transform it, and then display it in a front-end application, for example, either in the playground, or you can power the actual application front end, whether it be a website, etc. Okay, so let me jump back into the slides here. We went through the 4 commands, we went through that. We went through the demo project. This was the multi-chain indexing we went through. So just a note on the NFT side, I will be creating a video on an NFT example. I didn't want to, just based on time, I know we're at 38 minutes past. I've thrown a lot of information at you, but I wanted to give you the fundamentals first before jumping into the more advanced stuff. So I'll be sharing that in the various channels, in Discord, in the to Kevin as well, and I'm sure he'll share it out. But just a quick wrap up here. If you do want more information, feel free to visit our documentation site. So that's academy.subquery.network. Here's a specific link to the multi-chain support and docs as well. Feel free to jump into our Discord at Subquery. We'll also jump into the Moonbeam one and provide support there as well. Do note there is a Moonbeam course that we collaborated with Moonbeam earlier, late last year actually. That's on YouTube, so there's a link there. And of course the link to our website as well. So with that, I hope you found the workshop useful. There was, again, a lot of information thrown at you, but I'm sure that you guys, as very competent developers, will be familiar with this. It's just a matter of getting your hands dirty, a couple of lines of code, and spinning up the project in Docker, getting the information, and just working from there. Yeah, let me open up the lines, hand it over to see if there are any particular questions you have.
So go ahead. There's also a Q&A box, but the chat is perfect. So if anybody has any questions, please drop them there. So Sean, I wanted to start with the dumb question, which I apologize for. But you showed us the Polkadot endpoint, the WebSocket endpoint in a configuration file. Was there a similar one for Kusama as well?
Yes, let me.
Okay, cool.
This one here, yeah.
Awesome.
Yep. And what's interesting is that only recently we upgraded the feature here because you can only provide one endpoint, but now it's actually an array. So you may have noticed the Polkadot one. If this one fails, it'll try the next one.
That's huge. That's a big deal. That's amazing.
There's a question coming through here from Darren. Are the Docker containers basically local nodes that talk to different chains? Yes. So it's a local node that Spring Docker. Yeah. Yeah. So these are the nodes that I wouldn't say it talks to different chains. It actually is the chain itself where we get data from. But it does talk to the Polkadot chain, for example, and this is what the project interacts with in order to get the data. So as another example, you can actually run this node locally on your laptop and not use Docker at all, right? A lot of people do that, but what we found is that the development experience with Docker is just so much faster because we're talking minutes. Just to create a quick POC, for example. I mean, if we have different multi-chain projects, yes. So with different multi-chain projects, Polkadot, Moonbeam, what you'll do is, let me show you the Docker Compose file. You'll see here we've got the Subquery Polkadot one. We've got the Kusama one. So if you wanted to do a Moonbeam one, all you do is do this, copy, right? Copy this, paste that in here. You'd rename it to Moonbeam, A star, whatever you need. And then you'd give it a different port because you don't want to port conflicts. So we've got 3000, 3001, 3002. Call this Moonbeam. So, and if we run this, we just change the YAML file as well. We need a specific YAML file, right? And of course, we'd make another YAML file here. We'll copy and paste this, and we'll have the Moonbeam endpoint, etc. In fact, why don't I just I won't actually do it, but this is what it would look like, right? I'd go Moonbeam like so. You'd have to modify these ones, and then you'd run the project again, and then you would have another node here called Moonbeam. So it really makes multi-chain, getting data off different chains really, really quick. And I can't stress quick because us developers, we're impatient, right? And often you're hacking away, and the deadline's like in 3 hours. It's like, how do I do it now and add it into my presentation? I mean, this really helps.
That's huge. So I had one more question regarding like revisions and stuff, right? So let's say we build out our project. Let's say we have like the following fields. We have like name, description, and price, but we forgot to add owner. What would the revision process look like? Like where would we have to make these changes just to add a field? Say like we want to add like the owner field of the NFT.
Yeah, awesome question. I'll do it here actually. And I'll give you a demo. So you find you miss a field, right? So let's go to your schema file. Let's go owner, right? Chuck this in. Owner will be a string. So if you can put an exclamation mark to make it a compulsory or a mandatory required field, or just leave it off. Now, what you do is you save this, and then you run yarn code gen again. You must regenerate the types. So you go yarn code gen. Let's go this one here, like so. And what will happen is that the types will auto update in here to include an owner field, right? Because there's no owner in here, right? So owner will appear here. And then what happens is, again, for development purposes, because you don't have that field, your database table has already been set with the column names. So you've got to blow away the database, right? So what you do is in your .data field folder, just delete this. And then you have to start indexing from your start block again, whatever that may be, because you've missed that field, right? The database hasn't updated and doesn't know about it. And if you don't do this, you'll keep running. It'll still work, but you won't see the information and you'll think something's wrong.
That was a very clear explanation. Thank you.
Yeah, I do this all the time. I mean, people love prototyping, they love agile development. I just do, block number to from, and then I run the code, get up and running. Oh, I forgot this, I forgot that. And it's just rapid iterations all the time.
For sure.
Which is what hacking is all about, right?
Oh, absolutely. Cool. Well, here we go. Darren's got another question.
Is there a downside from not starting from first block? Actually not. It's an upside actually, because quite often what you find is block number one is like 5 years ago, and when you start indexing, you've got to catch up, so it takes a lot longer. So what I do when I'm developing is I'll typically find the start block of the data that I want, and it will be something like 18,674,000, right? It's either the deployment of the contract or when a specific event has happened, and I'll make the start block that. And the reason why is, go to this one here, I'll update the start block here, and it just means that when I run the project, I get the results straight away. You saw me earlier inside the playground here. I was going, refresh, and there's nothing there. I go to the start block, and then you see data straight away. You can start working on it quickly, but it does depend on your application, right? So quite often, I actually never ever start from the Genesis block unless you want to get data from way back then that's important to you.
Something that's interesting about Moonbeam is that when Moonbeam first launched, it was just the substrate side of things, right? For the first month or so, governance is a little bit different, and then after that, the EVM is enabled, transfers are enabled. So if you're looking to index a particular contract, there's no need to start before the EVM existed or was live on Moonbeam, and that's somewhere around block 200 or 300,000. So that's already like a ways in.
Yeah, good point. One thing that I can point out is that if you do start from block one and there's no data there, the console will tell you, oh, sorry, there's no data at block one. The data appears at block 16,433,000. So then you, in the terminal, you can take that and paste it into your configuration file.
Oh, that's sick to hear. That's great. So if nobody has any more questions, I can just give like a quick preview in terms of what we have coming up this week, additional workshops and things like that. So if you haven't registered yet for the hackathon, I highly recommend that you do so at moonbeam.hackerearth.com. And there's still plenty of time, just over 3 weeks. But this week we still have 3 workshops coming up. So tomorrow at 10 a.m. Eastern, that's building connected contracts with Moonbeam, or yours truly. And then on Wednesday at 2 p.m. EST, we'll have the Biconomy workshop. And Thursday at 12 p.m. Eastern time, we'll have the Stealth Swap workshop. And then coming up next week, so that would be the week of June 12th, we have a bunch of different office hours with Chainlink and Moonbeam on Wednesday and Subquery on Thursday. So if you find that you're working and you have questions, you don't need to wait until then. You can just jump into the Discord. Sean mentioned either the Subquery Discord or the Moonbeam one. There's a hackathons channel in Moonbeam, and we're going to be watching that very closely. And if we can't answer your question, we will find somebody who can. And definitely don't want you to get stuck for too long. Thank you so much, Sean. This has been a fantastic workshop. It was hands-on. As you mentioned, you learn best when you're doing stuff, right? So I really appreciate that you showed us exactly with the hands-on demos, right? You went from the slides right to doing the hands-on work, and I really appreciate that.
No worries. Thank you very much for having me, and I'm just lucky it worked because it was live. So we all know how that sometimes can end up.
That's perfect. It worked flawlessly, and thank you so much for doing the live demo. And we appreciate your participation in the hackathon and being a sponsor of the Bear Necessities Hackathon.
Oh, our pleasure.
Thank you so much, everybody, for joining. And this replay will be available on YouTube very, very soon. And thank you so much, and we hope to see you very, very soon.